Have you ever wondered how computers seem to know so much about us? From personalized recommendations on streaming platforms to self-driving cars, we're witnessing a technological revolution powered by machine learning. Imagine computers not just processing information, but actually learning from it, just like we do. This is the essence of machine learning, a fascinating branch of artificial intelligence where computers are trained on data to make predictions or decisions. Instead of being explicitly programmed for every task, these intelligent systems learn patterns and relationships from the data they're fed. The more data they process, the better they become at making accurate predictions. Think of it like teaching a child to ride a bike. They need to learn from experience by trying, falling, and adjusting their approach until they achieve stability. Similarly, machine learning algorithms learn from data, iteratively refining their models to improve their performance on a given task. This ability to learn from data is transforming industries worldwide, from healthcare and finance to marketing and entertainment. But how exactly do these machines learn? Let's delve into the fascinating world of supervised and unsupervised learning to understand the different ways machines can acquire knowledge. Imagine you're teaching a dog a new trick. You show it the desired behavior, reward it when it gets it right, and correct it when it makes mistakes. This is similar to how supervised learning works, one of the fundamental paradigms in machine learning. In this approach, we act as the teacher, providing the algorithm with labeled data, which essentially means data points that are already tagged with the correct answers. Think of a spam filter in your email. It's trained on a massive data set of emails, each labeled as spam or not spam. The algorithm learns from these examples to identify patterns and features that distinguish spam emails from legitimate ones. When a new email arrives, the filter uses what it has learned to classify it, protecting your inbox from unwanted messages. Another relatable example is photo recognition software. These applications are trained on vast data sets of images, each labeled with the objects they contain. By analyzing millions of pictures, the algorithm learns to recognize patterns associated with different objects, enabling it to identify cats, dogs, cars, or any other object it has been trained on in new, unseen images. Essentially, supervised learning is like learning with a set of flashcards. Each card has a question on one side and the answer on the other. Once it has mastered the flashcards, it can then answer similar questions it has never seen before. Just like a carpenter has a toolbox full of different tools for various tasks, machine learning practitioners have a variety of algorithms at their disposal for supervised learning. These algorithms are designed to uncover hidden relationships within labeled data, allowing them to make predictions about future outcomes. One of the most popular algorithms is linear regression, often used for predicting continuous values such as housing prices or stock market trends. It works by finding the best fitting line through a set of data points, allowing us to make predictions for new data points based on their position relative to the line. Another powerful tool is logistic regression, which is particularly well suited for classification tasks where the outcome is binary, meaning it has only two possible values, like yes or no. For instance, it can be used to predict whether a customer will click on an ad or whether a loan applicant is likely to default. Decision trees, on the other hand, are versatile algorithms that can be used for both classification and regression tasks. The choice of algorithm depends on the specific problem, the nature of the data, and the desired outcome. The impact of supervised learning is all around us, shaping our digital experiences in countless ways. Take personalized recommendations, for example. Streaming services like Netflix or Spotify use supervised learning to suggest movies, TV shows, or music you might enjoy based on your past viewing or listening history. By analyzing your preferences and comparing them to those of other users, these algorithms can predict your taste with remarkable accuracy. In the financial sector, supervised learning plays a crucial role in fraud detection. Banks and credit card companies use algorithms trained on historical transaction data to identify suspicious patterns and flag potentially fraudulent activities in real time. Medical diagnosis is another area where supervised learning is making significant strides. By training algorithms on vast data sets of medical images, symptoms, and diagnoses, researchers are developing tools that can assist doctors in detecting diseases like cancer at earlier stages. These are just a few examples of how supervised learning is transforming various industries. As data sets continue to grow and algorithms become more sophisticated, we can expect even more innovative applications of this technology in the years to come. Now let's explore unsupervised learning. Imagine a child playing with building blocks, discovering patterns and relationships without any explicit instructions. This is akin to unsupervised learning, where algorithms are presented with unlabeled data and tasked with finding hidden structures and patterns on their own. Unlike its supervised counterpart, there's no teacher providing the right answers. The algorithm must learn from the data itself, like an explorer charting unknown territory. Consider a scenario where you have a large collection of photos from a family gathering, but they're all mixed up, and no one is labeled. An unsupervised learning algorithm could analyze these photos, grouping them based on similarities in facial features, backgrounds, or other visual cues. This ability to find hidden patterns in unstructured data makes unsupervised learning particularly valuable in areas like customer segmentation. By analyzing customer purchase history, browsing behavior, and demographic information, businesses can use unsupervised learning to group customers with similar preferences, leading to more targeted marketing campaigns and personalized recommendations. Essentially, unsupervised learning is like giving someone a jigsaw puzzle without the picture on the box. Just as a detective uses different tools to solve a mystery, unsupervised learning employs various algorithms, each designed to uncover specific types of hidden structures within data. These algorithms excel at finding patterns, grouping similar data points, and reducing data dimensionality, offering valuable insights in a myriad of applications. One such algorithm is k-means clustering, a workhorse for grouping similar data points into clusters. Imagine wanting to segment customers based on their purchasing behavior. K-means clustering can group customers who purchase similar items together, allowing businesses to tailor their marketing strategies for each group effectively. Another powerful tool is principal component analysis, or PCA, which focuses on reducing data dimensionality while retaining as much variation as possible. Think of it as finding the most important ingredients that explain the most variation in a dataset. PCA is widely used in image compression and noise reduction, where it helps simplify complex data while preserving essential information. Each algorithm offers a unique approach to uncovering hidden structures within data, providing valuable insights that can drive informed decision-making in various domains. Unsupervised learning, with its ability to find hidden patterns in the wild, untamed wilderness of unlabeled data, is making its mark across numerous fields. One area where unsupervised learning shines is anomaly detection. Think of credit card companies needing to identify fraudulent transactions. By analyzing normal spending patterns, unsupervised learning algorithms can flag unusual activities that deviate significantly from the norm, helping prevent financial fraud and protect consumers. In the world of cybersecurity, unsupervised learning plays a crucial role in identifying and responding to cyber threats. By analyzing network traffic patterns, these algorithms can detect anomalies that might indicate malicious activity, allowing security teams to respond proactively and mitigate potential breaches. Recommender systems, a staple of the e-commerce landscape, also benefit greatly from unsupervised learning. By analyzing user browsing history and purchase patterns, these algorithms can recommend products that users might find interesting, even if they haven't explicitly searched for them. Imagine two students preparing for an exam. One diligently studies from a textbook with clear explanations and practice problems, which we'll call supervised learning. The other explores the subject independently, drawing connections and forming their own understanding, akin to unsupervised learning. Both approaches have their merits, leading to different learning outcomes and strengths. Supervised learning, like our diligent student with the textbook, excels when we have labeled data and a clear objective, such as predicting a specific outcome or classifying data into predefined categories. It's like having a teacher guiding the learning process, providing feedback and correcting mistakes along the way. Unsupervised learning, on the other hand, thrives in the realm of exploration and discovery. Like our independent learner, it dives headfirst into unlabeled data, seeking hidden patterns, relationships, and insights without explicit guidance. The key difference between these two approaches lies in the use of labels. As we stand at the cusp of a new era powered by artificial intelligence, machine learning, in its various forms, is poised to play an increasingly pivotal role in shaping our world. Both supervised and unsupervised learning, like two sides of the same coin, offer unique strengths and contribute to the advancement of AI in complementary ways. Supervised learning will continue to drive innovation in areas like medical diagnosis, financial forecasting, and personalized recommendations. Unsupervised learning will be instrumental in uncovering hidden patterns, detecting anomalies, and generating insights from the ever-growing sea of unlabeled data. The future of machine learning is bright, and it's likely to involve a combination of both supervised and unsupervised learning, along with other emerging paradigms like reinforcement learning.